Hello and welcome to Shipbuilding PLM Insights. This is the third of a series of online sessions about PLM in marine and offshore. My name is Matthias and I am your host today. We at PROSTEP work with companies and manufacturing industries to implement digital continuity and traceability. We help our customers to develop increasingly complex products in an ever-changing business and IT environment. We support you to build the PLM environment you need to address the challenges of today and tomorrow. Being a vendor-neutral PLM solution provider, we have a deep expert knowledge of PLM, many PDM, ERP, and CAD systems, and maintain technology partnerships with all major vendors in the market. Our background in industries like automotive, aerospace, defense, shipbuilding, and transportation enables us to provide synergies to our customers. Over the years, we have worked with many companies in marine and offshore industry throughout Europe, Asia, the Pacific, and the Americas. We can see how globalization shifts market shares around the world. Changing cost structure, technological progress, and economic development are the driving forces behind this ongoing process. Companies must specialize and become highly efficient to remain competitive. We have been observing this process for more than 2 decades and can provide insights into shipbuilding and other industries from various perspectives. In our first 2 episodes, we have been discussing with you the interaction of CAD and PDM and collaboration. In our today's session, we will speak about the interaction of PDM and ERP. By the way, question and answer panel is open and you can start asking questions and make comments right away. We will look into them towards the end of our session. While data in ERP mainly focuses on what does it take to build the ship, PDM is more about the question, what does it take to meet the requirements specified in the contract? This results in different breakdown structures, often referred to as E-BOM and M-BOM, reflecting the design perspective, such as system-subsystem breakdown, versus product realization perspective, such as assembly steps and work packages. Shipyards use different build strategies depending on their logistical capabilities and manufacturing approach, such as yard internal section pre-outfitting versus turnkey supplier for specific systems or spaces. This has an impact on the interaction of PDM and ERP and needs to be addressed by shipyards in order to be flexible and efficient at the same time. Today we are going to discuss one of the most important topics related to PDM-ERP interaction. This is how material master data is best handled in a shipyard and how parts and materials are linked in both a make as well as a buy situation. This fundamental relationship of product design and realization is one of the longest experiences PROSTEP has had in its history. We helped develop best practices in many companies across all industries and have advice or can give advice and provide solutions to both business and ID. With me today is my colleague Nils. Hello Nils. Nils' university background is marine technology and shipping management. He has done a professional training in production logistics and process optimization at a large German automotive OEM. He works with PROSTEP as a PLM consultant since 2019. Before joining PROSTEP, he was a logistics expert in the German Armed Forces, where he was responsible for complex transport operations. In the first part of today's topic, he is going to discuss some basics about the interaction between PDM and ERP in a ship development project. Nils, it's your stage.
Yes, thank you, Matthias. Thank you, Matthias, and a very warm welcome from my side too. I guess it makes sense to start with some basics, just to get a common understanding. So, PDM-ERP in a shipbuilding project, what does it mean? If we are starting from a very basic point of view, every product, and it doesn't matter if it's this television here we are showing right now to you, or is it a very complex one like a ship is, every product has to run through a development and a realization process. Within this process, responsibilities have specific needs, and some examples are shown here on the left. For example, the 3D model is, I guess, the most common and the belonging drawings to it. But also manufacturing data or test and trail documentations are present here. But for now, if you are more interested in CIX PDM integration topics, check our episode 1 of this series. There, my colleague Jan Bitomski stressed this topic already. For now, let's focus more on today's topic, PDM-ERP. Integration and downstream processes. This means, in fact, the interrelation of development and realization. In terms of shipbuilding, fundamental needs for the product realization are similar to other industries. For instance, companies have to deal with planning of resources. There are these examples, so raw materials, machines or labor, but also manufacturing assembly structures, work orders, purchase process, budgets, costs and hours, and so on. It's just here an example. There are many more topics. So, but let's say the devil is in the detail. Due to the specific characteristics of a one-of-a-kind product, the capabilities of an ERP system, so to say, the system that realize the realization need to deal with existing specifica of a shipyard. As already explained, an ERP system is a system that is used to cover the requirements from realization process. In history, these requirements were mainly stressed by stakeholders from the manufacturing core, with capabilities like manufacturing resource planning, or before that, the material requirement planning. I guess everyone who's involved with ERP topics are knowing this core functionality. But over the years, ERP vendors developed and added additional capabilities to their portfolio. As a reaction of the increasing amount of stakeholders, like suppliers, design, and so on, of course, there are many more, like the guys from the controlling, and so on. So human resource capabilities are not mentioned here, but they're all, they're all present today. However, a long time, common ERP software vendors were not able to provide suitable solutions, so that shipyards were pushed to develop their own ERP system. And still nowadays, on many shipyards, homegrown systems are in place, often more focused on manufacturing than on topics like finance topics. But at the end, it counts that doesn't matter if it's a standard ERP solution or a homegrown system. Software capabilities nowadays have to fulfill the needs of the shipyard. Further, we will focus more on the technical topics today and not on the finance ones. In the second part of the episode, I will add examples from shipyards to some of these mentioned capabilities here. So, if we are talking about the development and realization, we have to talk about structuring information in a suitable manner. So the first question what we have to ask is, which structure do we need and why is it like it is? For the development, which is the design intent perspective, designers want to group parts as assemblies that fulfill a specific function, because we as a designer typically develop this specific function, and afterwards we want to bring the parts to a joint approval process. This means on a structural level, in an E-BOM, the engineering BOM, which is shown here, groupings are typically based on a functional nature. And for shipbuilding, this grouping follows a standardized classification terminology, here also shown on the left, like the SVBS, the SFI, and so on. In Germany, for example, we have the Marinebaugruppen-Verzeichnis. This classification helps to capture required systems of a ship in a consistent and structured way. So on the right side, there we are looking from another point of view, the logistic point of view, let's say, what could be, and it is, different from the left side. Here we want to move and monitor physical assemblies continuously, and therefore assignment of a material number in a system is required. An example could be that we want to put a material on a stock or an assembly on a stock, and for this specific putting on a specific storage place, we need this material number. Or another example would be that we want to allocate this material to a specific workstation. So this means that the required structure at all needs to be aligned with the production layout of the shipyard in order to plan and execute the product fabrication. But I guess this was just some basics. Let's come to some more practical, I guess. So let me hear, or what is shown here, the interaction of the EBOM and the MBOM, and how it could look like is shown on this overall shipbuilding process, which starts at the very beginning with the pre-contract phase and goes all the way down to the delivery. First of all, and this is one of the most important points, is because of the manufacturing strategy in shipbuilding, EBOM and MBOM mostly runs parallel, and information need to be permanently exchanged. But this is not enough. This permanent information exchange needs to be in both directions doable. So in this first loop, the EBOM is initially created during the pre-contract phase. There, in this phase, the shipyard defines the systems and requirements for the systems together with their clients. At this point, the information are used for initial estimates as well as for supplier communication. An example would be the main engine. The delivery time is very, very, very long, so it could be more than a year or 1.5 years, and that has the production from the production side has an effect on the production side. But MBOM needs to follow immediately. Why? To enable the estimation of a delivery date is a great example. Knowing systems is there not enough. The shipyard need to know what to be built, and in detail to enable the estimation of the required capacity from production side. Therefore, the MBOM is used to synchronize with the current production load. Afterwards, when this is done, it goes back via the MBOM, and the design can be scheduled reverse in accordance to the expected date in the production, which is given from the MBOM. When the design is approved, here on the top, it goes back via EBOM and feeds the MBOM with the design data. So at this point, the detailed scheduling and execution of the production can follow. In the second red loop, I'd like to show an example for change process due to an imperfection that is recognized from the production down there in the EBOM. Let's say maybe one example, a faulty design has happened, and now this is just recognized in the production, and now this problem is coming up, and production realized that, okay, that design is not productable. Thanks to the linked structure, it is shown which systems are affected so that the design can be adapted target-oriented. After redesigning on the top here, data can be transferred via the PDM system back to the ERP system, where the work planners can replan assemblies if needed and forward afterwards design to the production. Last but not least, within this last step on the right, the EBOM comes more back to the foreground because systems need to be tested and approved against the initial defined requirements after production and installation. I guess this makes sense. You do not test an assembly or produce assembly, you test the systems itself. Yes, and this more or less brings us not only to the end of the shipbuilding process, this brings us also to the end of the first part of this episode. So maybe at last, for this first part, let me sum up what we know so far. During the overall creation, a ship runs through a development and a realization process. Each of these processes has its own required work breakdown structure due to the different perspectives of the process stakeholders, the EBOM and the MBOM. But nevertheless, both of these stakeholders are dependent on each other. So EBOM and MBOM, the last point here, runs mostly parallel, and the information need to be permanently exchanged into both directions. So that's the first part from my side, Matthias.
Thank you, Nils. Thank you. You mentioned some of the standard capabilities in ERP, such as part and material master data management. This master data must be in sync between product design and realization planning, as you explained when talking about EBOM and MBOM. Thinking about shipbuilding here, can you please give us a bit more specific example from your recent projects?
Yes, Matthias, I will try to, and I guess master data management is a good example to explain interaction of PDM and ERP a little bit in detail. And moreover, according to my experience, and I guess your experience are the same, currently many shipyards are interested in this topic. So what is meant by master data management? I guess let's start. In this scenario here, I will show the material master, what is one expression of master data management. And here, at first for a make part. Material master in this case, or for the understanding, material master means that the leading information for the part creation is coming from the material master record, which is managed normally, and that's totally okay, managed in an ERP system. And make part means that this part will be manufactured by the shipyards themselves. I guess that's just for common understanding. So when designers start their work, they always have to consider certain dependencies from the realization side, which limits their design space. For example, theoretically, a designer is able to create every kind of product, so to say, handmade, but least when this product, when this part needs to be produced, the purchasing or production is facing into problems, I guess. So the purchasing needs to find and order a suitable raw material or prefabricate material, but because due to the uniqueness, that could be a big problem for them. And in addition to that, the production has to find a way to handle this with their existing manufacturing capability efficiency. So the second point is that designers don't want to recreate every repeatable part again and again. That would take way too long. Instead of that, direct access to a categorized part template in a design app that would improve the help. But now you may asking yourself creation and using of templates in design apps, isn't that a standard functionality of a design app? And then I can say, yes, it is. But the difference here in this content is that this data are not connected to the system that specifies the up-to-date information for this template. With the consequence that the creation and permanent maintenance is labor-intensive work. Here we are talking about material master management. That means that the presented predefined design options are continuously synchronized with the material master information in ERP. And it has the benefit that manual maintenance of the siloed information is not necessary. And further on, time-consuming approval workarounds are not, can be avoided. So, here the designer select just out of the template which profile type he wants to have and in which material grade. And like I explained, it's synchronized with the material master record from ERP so that he get just some solution provided that fits from purchase and production base. So, okay, then at a certain point, the design is ready, reviewed, and approved. In the following step, it can be forwarded to the ERP, where it's linked automatically to the MBOM structure node by its given attributes. This is another topic, this allocation to MBOM, which is very common today. Because of the continuously linked data, the assignment of one specific raw material at the end from stock is obvious simply, let's say. So I know this profile, this specific profile from the stock is allocated to this part in the MBOM structure node that is shown here. Finally, at this point, all informations are viable to carry out the work. Last one here. In our second scenario, the designer wants to create a design part for a purchase part. In this example, a pump. So instead of doing ordinary design tasks, the designer here accesses a catalog via the PDM system where he can view all pumps that are viable from technical and supply perspective, let's say, with, of course, the technical and supply relevant informations. After these selections, the process for the next step is similar to the one of a make part. Means after review and approval step, the buy part can be forwarded and linked to the MBOM, like it's shown here, in the ERP. Last but not least, purchase process can start in order to provide a delivery aligned with the planned installation date. Okay, I guess this was not just a little bit small scope. There we are triggered a little bit more other topics, but here we have concentrate on the make and buy part in relation to the material master management. And at the last point, yes, I hope that I was able to show how strongly these two systems are dependent on each other and how important a good collaboration between the systems is. For now, I'm more than happy if we were able to give you some impressions regarding to PDM-ERP integration in downstream processes. Of course, I already said that, we were showing, let's say, just a small but very valuable screenshot from a bigger picture PDM-ERP, and no doubt there are many more scenarios that we would like to discuss, maybe with you, maybe in another episode, or in a direct conversation. Last but not least, for all of those who have just tuned in, or even for those who did not get everything from that what I've tried to express directly, I know it's not so easy, this topic. Please keep this one message in mind. Technical integration must allow integration into both directions, flexible and configurable to each shipyard. Thank you very much. Matthias.
Thank you, Nils, for this nice overview about how design parts and materials are related in a ship development process. So what we learned in the second part of Nils' presentation is different scenarios like make or buy have different requirements that need to be handled by shipyards. Both require ERP-based material master data being made available to the designer in both PDM and CAD. Parts created by designers need to be provided to resource management for material requisition, purchase and production planning. If there is a change, this needs to be updated at both ends and kept consistent at all time. And this means PDM and ERP interaction is a two-way process that is going on during the entire ship development phase. In the last part of our session, we would like to get your feedback, as usual, I must say. If you haven't done so, you can now leave your questions and comments in our Q&A section. You might have to leave full screen in order to be able to do so. So let's see if there is any comments or any questions in the list already. I can see one. The question is from Timu. I like to know how you explain the complex topics in a simplified way. In part 1, you told us there's an E-BOM and M-BOM. Which of the BOM we need to transfer to the ship owner? Probably at the end is delivery of ship. Yeah, thank you, Timu, for this question. It's a very great question, so I will try to answer that and let me think about that. Okay, we have the E-BOM and the M-BOM. We said the E-BOM is for the development, and the M-BOM is required for the realization process. So as a ship owner, so the client of the shipyard, I'm not interested in all content of an E-BOM and all content of an M-BOM. So it should be a combined version. The so-called S-BOM is something, or an as-maintained BOM is something what the ship owner is interested in. Therefore, examples are content from the E-BOM, like the specification of a pump in case of maintenance, which will follow during the years. During a class approval, you have to change things. Then you look into the specifications. If these
this exact pump you have installed is not viable, that you can use another pump. But there are also informations needed from the MPOM, like materials certification, when the class approval comes. This is also interested content for the ship owner. So normally it's not only the EBOM or MPOM you're not able to consider. It's an SBOM which combines parts of EBOM and MBOM, and this is something what's important or usable from owner perspective.
Okay, thanks. Maybe worth mentioning also, of course, shipyard is also a stakeholder in this business, and not every piece of information that exists in the shipyard as part of the ship development process, the shipyard wants to hand over to the ship owner at the end. So there is always kind of a balance that needs to be found for the information that is being transferred between shipyard and ship owner at the end with the delivery of the ship. Both have their interests and both have their rights in information, and they both need to be addressed and taken into consideration. So let's see if there is another question. Not so far. At least I have nothing more in my list at the moment. Okay, let's wait for 10 more seconds. If there is somebody else entering a comment or a question. This seems not to be the case, so we carry on. If there is any more comments or questions coming up at the end, we will show you how you can contact us, and feel free to send us your questions also afterwards offline per email, for instance. As we did in our first two episodes of our series, also today we would like to ask you to help shaping the content of our fourth episode of our series. For this, we again have 3 proposals for you to choose from, and you are now invited to the poll, and please make your choice. I'm introducing the 3 options to you that you can choose from. So for the next session, which is episode 4, we propose option A, to prepare a demo session about what we have been discussed and shown in topics 1, 2, and 3, which was CAD PDM integration, collaboration, and PDM-ERP integration. That's what we are looking at today. This would be option A. If you would like to see a demo, how this looks in reality, how it looks in real systems, how data is being exchanged as part of a CAD PDM integration or as part of a collaboration or between PDM and ERP, option A is yours. Option B would be a new topic to talk about, which would be digital class approval. So digital class approval more and more gets traction. We are in discussion with several classification societies and have been over the last few years, and this is more and more coming on the agenda of both shipyards as well as classification societies, becoming more digital, trying to replace drawings as part of the class approval process. If this is something you would like to see in our next episode, option B is yours. And last but not least, option C, we propose to have a discussion together with you, maybe also a bit more interactive, about the transition from drawing-based to model-based development process. So as we all know, today in most of the shipyards, drawings are the primary work products, and drawings are used to plan and to terminate all the processes. This is in other industries like automotive already on its way to be moved to model-based, and this would also be a good option for shipyards and for shipbuilding industries in general to take a look at and to discuss how this can be achieved. So if you would like to see and to be part of a discussion about the transition from drawing-based to model-based development process in shipbuilding, then option C is yours. So please, you are now invited to the poll. Please make your choice. we give you a bit time to do this. Okay, a few more seconds to go. And then we will display, or we will see the result. Okay. So my technical colleagues, I can't see any results. So, okay, it's still it's still computing. So it seems to be a complex transition to go. Aha. Okay, here we go. Oh. Okay, so we have two of the options that are more preferred, and one of the options that is not of so much interest as it looks like. Not of so much interest is option B, digital class approval. Okay, and the two options that are of more interest are option A and C, with a bit of headway for option A, demo sessions about what we've been showing and discussing in episode 1, 2, and 3. So for now, for our first session today, option A is the winner, but not much behind. Option C is following. So let's see how this evolves during the day, because as you probably know, we have a second option in our afternoon. So maybe people are voting differently there, and we will basically consolidate the results of both polls at the end, as usual, and keep you informed about the end result of the poll. So for now, for our current session, option A is the winner. Okay. We are now coming to the end of our third episode of Shipbuilding PLM Insights. Thank you very much for your, again, interest and your active participation. We would be happy if you were able to take away some ideas for your current and future PLM activities. Thank you, Nils.
Okay, we got feedback from our technical guys that there are additional questions.
More questions.
Do we want to answer, or do we have the time?
Yes, we still have some time. Sorry, I didn't notice. So we are rewinding a bit. Oh, obviously some questions got stuck in the queue. So let's see what it is. Okay, Mr. Yi. How to handle multiple M-bombs for 2 or 3 shipbuilding locations of a shipyard group?
Here it is. Okay. Well, let me think about that. It's a great, fantastic question. So I have to think about the answer, because it's not that easy one, and I guess there's mostly not one answer that is given as a totally best solution. If you have multiple shipyards where you have to produce a ship, you need a specific M-bomb for every shipyard. I guess it's clear, because to the different facilities, how this facility or production is structured itself. Sometimes maybe they have some producing workstations, which is unique for the one shipyard, and the other shipyard has not this capability to do that. So one solution, what we see very often in other industries, is that a general M-bomb is maintained or prepared in the PDM system, where the upper structure is given, and this is something where the design is run over, and in a second step you have to split this general M-bomb to a specific M-bomb for each shipyard. This can be prepared, like I said, in a PDM system. In other industries they do it very often, because they trigger these, let's say, work planning or production planning topic from PDM side and hand over just the expectations to the ERP system. But this is not that you have to do it like this. An ERP system can do that also. So, but the point is, a generic M-bomb is then, I guess, more or less a good solution to have it, and afterwards to split into specific M-bombs. When you do it in an ERP system, you have to think about a clear maturity process and things like that. That is something you have to consider. in PDM system, this is nearly the same like for the development process. So that's sometimes the reason why PDM systems are chosen. Matthias, do you have there additional comments?
Yeah, I think stepping back from the tool discussion a little bit, it's basically about the processes, and in a roughly spoken, you have a design process, and you have a work preparation and manufacturing process, and then you have the manufacturing process. So if you have several, 2 or 3 manufacturing locations which have different capabilities in terms of crane capacity or other logistic capabilities and workforce and machinery, then of course you need to have a work preparation, a manufacturing or production engineering which is suitable for those specific requirements. And it might well be that this production engineering, work preparation is located locally to those different manufacturing sites. If this is so, then of course you will have your MBOM development locally in the different manufacturing sites. If your manufacturing engineering or work preparation is a centralized entity in your company, then you might have this at a central place, and you might have a central generic MBOM in one of the systems that is used at that central place, main shipyard or whatever it might be. And then it very much depends on what are the technical capabilities of the manufacturing locations. Do they have their own local production system, ERP system, or are they basically or is the central entity providing this capability to the local production sites? So there's a variance or a bandwidth of typical or of constellations that you can think of, and there's no one fits all solution, but it always has to be taken into consideration how is the specific situation in a specific company or group of companies that are trying to build ships designed at one place and built at different locations. Which brings us a little bit to the questions that Stanislav brought up. Thank you for this. So Stanislav basically raised 2 questions that are related to each other. First one is, should a shipyard use the same ERP PDM system as a design company? So I take this as there is a design contractor and a shipyard, and they are both using systems like PDM and ERP. And the question is, should they use the same or can they be different? And related to this is, please indicate what software or a combination of software could be used as ERP or PDM system.
Okay, first question first, let's say. Okay, I guess there is no, could you maybe repeat the question? What?
The first one?
Did I get it right?
So
yeah?
Should shipyard use the same tools as design company?
Yeah, most often it's different. So the design company use the tool that the shipyard use. Sometimes the shipyards try to pressure them to do that because for the workflow it's easier. And but I don't think that this is the solution. There are always different applications in use, and it's not that easy to say, okay, always standardize, always use the same tool. There are reasons for using different tools. Maybe they have their own characteristics with their own capabilities, which are in foreground from the design, and the shipyard has a focus more on manufacturing design, let's say, perspective. That could be one reason to distinguish here. If you say, okay, everyone use the same tool, you have to find a common way for doing this. And this, from our perspective, I guess, and Matthias will agree, that's not so easy. So more important is that this collaboration between the software, so integration from one software to another, that this is well prepared and good to realize at the end. And this is more or less a solution, and this is something what is PROSTEP known for, the integration topic, and this is what we do since decades. And I guess this is the better approach to fit all needs from all perspectives, and not to say, yes, use one solution.
Yeah, and maybe
Yes.
to add, if the engineering company is not integral part of the shipyard itself, but an independent entity, then they might work for other shipyards as well. So other shipyards might again have other systems, and then the engineering company would have to have a number of different systems depending on which shipyard they are dealing with in the specific project. So it doesn't really, in reality, it's very difficult to achieve a situation where everybody uses the same software. And that's something that, as Nils pointed out correctly, is technically no problem today. So it's resolved how to link and how to move data between different types of systems and between different systems of the same type. But it's more about talking about the processes and talking about who is responsible for what and how is the process going. This is the more important thing, and then you find a technical solution.
I guess
for this.
Second question.
Second question was, can you give some recommendation which software or which combination of ERP and PDM systems should be used by a shipyard?
To be honest, I don't want to give there an advice on that. Is not our job to say, okay, use this system or that. More often we do for shipyards, for example, some kind of benchmarks, and afterwards we make a proposal for the best solution for their needs. So to say, okay, this or that big vendor software is the best for PDM, or the ERP system XY you have to use. That is not the answer we can give here directly, okay, this is the best and this is the worst. It depends on the requirements from the shipyards, to say.
That's exactly it. So even if you wanted, we cannot answer this question today saying shipyards should always use this PDM system. There are a number of well-known vendors in the market that are also having a footprint in the shipbuilding industry, which might be a good indication to look at those vendors that already have some background and already have customers in this industry. That would be one criteria. And there are a few. Then, of course, it very much depends on what exactly are you intending to do and what are your requirements, how big is your company, how many partners and how many manufacturing locations you have to deal with, how big are your ships, how complex are your ships, and this is again why there is no one-size-fits-all solution, but we would have to look at your specific situation, and we very much would be in a position and appreciate to help you with this. One last question, and then I think we are running out of time, but there's one last question from Ismo, and Ismo is asking where the place of a manufacturing execution layer or system is in our story. So he's basically asking MES, how do you position MES to PDM and ERP? Yeah,
answer is a little bit conducted to the answers before. More often than never, an MES system is more or less integrated to ERP system. But this is not the solution we can give. There are also approaches that do these MES in a line to the PDM system. So let's think about ERP and PDM system. It could be also a standalone solution. The answer we could give here is also to say the collaboration and integration between ERP, PDM, and MES system. The MES system needs information from both systems, so the position is not totally defined that you can say, okay, do it in the ERP or PDM or do it outside of both. It depends on the requirements and how the workflow works best for you.
Yeah. And from my side, I can maybe comment on this in a way that I can give you two answers. Process-wise, the position of an MES system is behind ERP. PDM comes first because it's basically the system that is controlling the design data and managing the design data. ERP is basically coming next, even if the two are somehow in a concurrency because of concurrent processes in development and manufacturing on a shipyard. But downstream, ERP is the system that's following. And then manufacturing execution, as the name suggests, It's the system that is basically controlling the execution of the production, of the manufacturing. So as a tendency, it comes downstream after ERP, process-wise. From another perspective, as Nils already indicated, if it comes to exchanging information and keeping everything in sync, then you can think of a triangle between PDM, ERP, and MES. It's basically three different classes of systems that somehow need to be in each and every company. From a concept perspective, doesn't necessarily mean that you have to have three pieces of software. Could be so that it could be combined into two pieces. That's, again, this discussion about tools. But at the end, you basically have to manage this threefold constellation of software, enterprise software systems that are all dependent or relying on each other if it comes to having synchronized data available and up-to-date data available at each point in time. Okay. So this is basically the questions. So I hope we didn't miss more questions, but I think we are running a bit out of time, so we should basically conclude for now and maybe continue discussion offline if need would be.
And
so
if you have already some questions present or later some questions coming up, don't hesitate to write them to us. Our email address are here, I guess. If there are more questions to ask, feel free.
Yep. Okay. So again, thank you very much for your interest and your active participation. We would be happy if you were able to take away some ideas for your current and future PLM activities. And thank you, Nils, as our today's speaker.
Thanks.
And again, a special thank you to our technical team behind the scenes that worked hard to make this all possible. And we are right in a sauna type of environment here, so it's quite warm in southern Germany today. We hope you enjoyed this session with us today. We definitely did. If so, please share it with your colleagues, partners, and friends. All the best. Stay safe and healthy. As always, my name is Matthias. I am looking forward to see you again soon for our next episode of Shipbuilding PLM Insights. Take care and see you next time. Bye-bye.